Scenario: a block slides down a distance L along the ramp from rest. The ramp makes an angle theta with the floor. Question: assume the ramp has negligible friction. What is the kinetic energy of the block at the bottom of the ramp? The answer: the approach is going to require us to use conservation of energy because the total energy at the bottom is going to be the same as the top because the system is considered to be closed. Energy top is equal to the energy bottom. At the top, it is defined by kinetic energy, K top, and the gravitational potential energy, which I label U, G top. At the bottom, K top is the kinetic energy at the bottom plus U bottom, which is the potential energy at the bottom. We can substitute some values here. At the top, the object was at rest, so there is no kinetic energy. That's why K top was equal to 0. U bottom was also equal to 0 because there is no potential energy once the object touches the floor because H is equal to 0. Now you can substitute in some values. U G top can be defined by mgh, and K bottom, I'm just going to leave it as just K bottom because that's what I'm trying to solve for. The issue here is that we have to find height of the scenario that the block travels. You will have to be able to use trig here. The height here would be the sine component of the right angle because that is the up and down. That's the opposite side to the theta value. So height is equal to the length times sine theta. We substitute it in. mg, the h is L sine theta, and that will be equal to the kinetic energy at the bottom.